The autonomic nervous system, or ANS, is the part of the nervous system that regulates activities of internal organs. The ANS is largely autonomous, acting independently of the body's consciousness and voluntary control. It has two main divisions, sympathetic, SNS, and parasympathetic, PSNS. In situations that require alertness and energy, such as facing danger or doing physical activities, the ANS activates its sympathetic division to mobilize the body for action. This division increases cardiac output, accelerates respiratory rate, releases stored energy, and dilates pupils. At the same time, it also inhibits body processes that are less important in emergencies, such as digestion and urination. On the other hand, during ordinary situations, the parasympathetic division conserves and restores. It slows heartbeats, decreases respiratory rate, stimulates digestion, removes waste, and stores energy. The sympathetic division is therefore known as the fight or flight response, while the parasympathetic division is associated with the rest and digest state. Despite having opposite effects on the same organ, the SNS and PSNS are not mutually exclusive. In most organs, both systems are simultaneously active, producing a background rate of activity called the autonomic tone, a balance between sympathetic and parasympathetic inputs. This balance shifts one way or the other in response to the body's changing needs. Some organs, however, receive inputs from only one system. For example, the smooth muscles of blood vessels only receive sympathetic fibers, which keep them partially constricted and thus maintaining normal blood pressure. An increase in sympathetic firing rate causes further constriction and increases blood pressure, while a decrease in firing rate dilates blood vessels, lowering blood pressure. The autonomic nerve pathways from the control centers in the central nervous system to the target organs are composed of two neurons, which meet and synapse in an autonomic ganglion. Accordingly, these neurons are called preganglionic and postganglionic. In the SNS, the preganglionic neurons arise from the thoracic and lumbar regions of the spinal cord. Their fibers exit by way of spinal nerves to the nearby sympathetic chain of ganglia. Once in the chain, preganglionic fibers may follow any of three routes. Some fibers synapse immediately with postganglionic neurons. Some travel up or down the chain before synapsing. Some pass through the chain without synapsing. This third group continues as splanchnic nerves to nearby collateral ganglia for synapsing instead. From the ganglia, long postganglionic fibers run all the way to target organs. The SNS has a high degree of neuronal divergence. One preganglionic fiber can synapse with up to 20 postganglionic neurons. Thus, effects of the SNS tend to be widespread. In the PSNS, the preganglionic neurons arise from the brainstem and sacral region of the spinal cord. Preganglionic fibers exit the brainstem via several cranial nerves and exit the spinal cord via spinal nerves before forming the pelvic splanchnic nerves. Parasympathetic ganglia are located near or within target organs, so postganglionic fibers are relatively short. The degree of neuronal divergence in the PSNS is much lower than that of the SNS. Thus, the PSNS produces more specific, localized responses compared to the SNS.